Okay, so an example here, computing a derivative using the chain rule. Okay, so we've got this function h of x, and we'd like to compute its derivative. Okay, so the function is 4x plus 3 to the power 5. Okay, not a function we can take a derivative of using any rule we have in the past. The best thing we could do here, which we definitely don't want to do, would be to take 5 copies of this and multiply them all together, do a lot of math, and then get the function kind of expanded and then take the derivative term by term. Well, the rule we have now is one that allows us to take a derivative of a function if it's a composition of two simpler functions. Okay. So what the chain rule says is that if you want to find the derivative, I'll write it down over here, of f of g of x, so one function put inside of another, okay, you want to find the derivative of this whole mess. It's f prime, so the derivative of the outside function with the inside function put back in, times, let's see if I can fit in there, the derivative of the inside function, g prime of x. Okay, so really not a difficult rule to use, but we do need to figure out what these two functions are. Okay, this is a composition of functions. Okay, so let's think about this for a minute. I'm going to go back to h of x again. Okay, just the original function. Well, I can write this as a composition of two functions if I choose them carefully. And here are the two functions that are going to make this work. F of x is going to be x to the fifth, and g of x is going to be 4x plus 3. Okay, so these are two functions, certainly. But if I compose them together, if I take g and put it inside of f in place of x, I'll get 4x plus 3 to the power 5. Okay, when I compose these two functions together, I get the one I'm looking at. Okay. Well, once you can write a more complicated function as two simpler ones composed together, we know how to take the derivative. It's very easy. The chain rule just says take the derivative of the outside function. Okay, well, what is the derivative of the outside function? Well, it's going to be 5x to the fourth, right? That's the f of x. It's x to the fifth. Derivative is 5x to the fourth. We also need the derivative of the inside function. Okay. Well, g of x, the inside function, is 4x plus 3, so its derivative is just going to be 4. Right? The derivative of 4x is 4. Derivative of 3 is 0. Okay. So back to the chain rule. Chain rule says take the derivative of the outside function and put the inside function back in it. Okay, I need f prime of g of x. So I take g and put it into the derivative. That'll give me 5 times 4x plus 3 to the fourth. Okay, see what I did there? Put the function, the inside function, into the derivative of the outside. Okay. And then I need to multiply by the derivative of the inside function, which is just 4. Okay, that's the answer. The derivative of this very complicated function, which we can't find using at least a simple process in our old rules, is just 20 times 4x plus 3 to the fourth. Okay, so of course it would have been a lot of work to multiply this out, and if we had done that, we would have got a derivative which was very complicated looking. Would have had probably 6 or 7 terms in it, and now we get a nice simple expression for the derivative, basically as simple as the original function was.